Hey guys, welcome back. We're going to talk about the power rule a little bit more today. So hopefully it sat well with you when you learned it last. We are going to dive a little deeper and get into some more challenging problems. But let's start with a warm-up. So just as a reminder, how do I find the derivative using the power rule? All right, I'm going to take the power of the first term. 10%. Let's see if we can get this done. Drop it down in front and multiply. -2 times 5 is -10. And then I'm going to take my power and drop it down by 1. So x to the 4th power. For constants, those go to 0. So I kind of just get to forget about them, and I'm done with my first problem. All right, number 2. How do I find the derivative? Same story. Drop the power in front. 3 times 2 is 6. X to the first power plus. All right, so this, remember, x's go away, but you do have to put the number that's in front of them in the derivative. In other words, this invisible power of 1 is going to drop down. I do have to write it. But then the x part goes away because the exponent drops to 0, and x to the 0 power is just 1. So this is my answer because the constant goes away. So f prime of x is 6x plus 1. Next example, number 3, is just a constant. Constants go away, but I do have to write something down. So for this one, I would just write 0. Okay, next one. If you hear some weird noises in the background, that's my son Dean. He's joining me today and hopefully will not be fussy during this video. Let's go ahead and find the derivative. F prime of x is just going to be 7. It's technically 7x to the 0. The constant goes away, so I'm done. Dean is 3 months old, so he will just make noises. And hopefully that's it. All right, example 1 of our new notes for today, transitioning from the warm-up, is the same thing as the warm-up. We're just going to get into some fractions, fractional exponents, radicals, and negative exponents. So just kind of stepping it up a notch. But we do the same thing. So when I find the derivative, I'm going to drop this 4 down. 3/4 times 4. You could use your calculator for that if you're not confident doing it in your head. But really, these 4's just cancel out, right? So that's just going to be a 3x to the 3rd power, okay, because the power drops down by 1. The next term will be minus 15x squared. Now let's talk about these negative exponents. It's the same story. Drop it down. So it's actually going to be plus -6. So I'm just going to change this to a minus. So -6x. Now here's the weird part. When I subtract 1 from the power, it goes to -3. Let me explain that using a number line. Remember that our power goes down by 1. If you think of a number line, if my power originally was -2 and it goes down 1, it's going to go to -3. Okay, another way to think of it is that we're just subtracting 1. -2 minus 1 is -3. I like to think of the number line, I'm more visual, so I literally picture a number line and I picture going to the left 1 spot when I drop my power down by 1. Hopefully that will help you guys with the negative exponents, but that's the answer. We're done. Okay, next problem, same story, just a little step up. Okay, drop down the fraction exponent, same story. So it's 5 times 5/2. Again, you can use your calculator. This is just going to be 25/2. X to the, I've got to drop this power down by 1, which literally means subtract 1. Again, I could use my calculator. If you did, you would type something like this, okay, into your calculator. I could do it in my head. 1 is equivalent to 2/2. So 5/2 minus 1 is 3/2, and that's my new power. So I'm not doing anything different than what you learned yesterday. It's just, harder with fractions. This minus x, so if I take the derivative, that's just going to be a -1. plus, all right, so guys, remember back in Algebra 2, this is why I love calculus, not to go on a rant, but every single thing you've learned in math up until this point applies into calculus. So the little rules you learned in Algebra 2, they weren't just for nothing. They come back here, okay? Some may say they come back to haunt you. I just say they come back, which is fun. Root x is the same as x to the 1/2. So that's that Algebra 2 thing that you guys learned. We worked with radicals and going from radical expressions to exponent expressions. If you think of root x as x to the 1/2, it becomes a lot easier to take the derivative. I'm going to drop down the 1/2. Half of 2 is just 1. And then x to the, well, 1/2, subtract 1, which remember 1 is 2 over 2. That gives me negative 1/2. Okay, I usually don't write that 1 in front. Okay, so that's a little bit more challenging, but I just want you to remember, it's the same rules as yesterday, okay? You are just going to always subtract 1 from your exponent. Subtract 1 from your exponent and multiply the first number by the original power. Okay, so now we're going to go transition into talking a little bit about slope and to kind of warm up into that. The next skill I'm going to have you guys do is find the derivative of a function at a given x value. So if I say, what's the derivative at x equals -1, all I'm going to do is find the derivative. So find f prime of x, and then take that answer and plug in the given value. So in this case, I'm going to plug in -1. All right, so let's do that. Find f prime of x. That's going to be a 6x squared. Okay, just dropped down, reduced the power. I'm doing the power rule here. Plus 2x minus 4. The 1 goes away. Now, to find f prime of -1, which just means the derivative at x equals -1, I'm just going to plug in -1. Right, Dean? Isn't calculus fun? I got him the cutest little baby book that's called like Math for Babies. It goes through the whole alphabet and it gives a math term for every letter. I love it. We've been reading it. So we'll see if he ends up being good at math. It's okay if he's not. I will love him no matter what. All right, so here's what I just did, guys. -1 squared is 1, is +1. So I get 6. 2 times -1 is -2. Minus 4. Oh, look at that. I get 0. Okay, so that's my answer. The derivative at x equals -1 is 0. You may be thinking, like, what does that mean? What it means is the slope at that point of the tangent line is 0, which actually means I found a min or max, but that's something you guys will go into in calculus. All right, let's do the next one. So again, I'm going to find the derivative. That's going to be a 12x minus 8. Okay, how did I find that so fast? I did the power rule. All right, next, to find the derivative at x equals 2, I'm going to plug in 2 wherever I see an x. So that's going to be 12 times 2, and then minus 8. Okay, so that's 24 minus 8. So that leaves me with f prime of 2. 24 minus 8 is 16. That's my answer. Good job, Dean. All right, so that's what this says here. Remember, the derivative gives me, what the derivative actually gives me is a formula, okay, to find the slope of the tangent line at any given value, at any given point. Okay, so I think of it as a formula. This is a formula. So I can use that formula to find the slope of this function at 1, at 2, at 3. I would just plug into the formula. Okay, you're fine. So the derivative is a slope formula, okay? And it's the slope of the tangent line at a given point. So if I wanted to find the slope of a tangent, okay, at, say, x equals 2, then I would take the derivative and plug in 2, which is essentially what we just did in those last examples. The answer I get will give me the slope of the tangent at that value, at x equals 2. So these next two problems are literally what we just did, but the wording of the directions is slightly different. Instead of just saying find the derivative at this point, it says find the slope of the tangent line at this point. Same thing that we just did. Finding the slope of a tangent line is taking the derivative and plugging in a value. Okay, so let's take the derivative. 3 times 4 is 12. X to the third minus, drop the 2, 4x, and the 8 goes away. And now we're going to plug in 4. So 12 times 4 cubed minus 4 times 4. Guys, I would just plug this straight into my calculator. I don't know if you guys know that we have this app that available on your calculators. It's this TI Inspire app. You can get it in self-service. It's this TI Inspire. So if I were you, I would literally just type in, what number was I supposed to plug in? 12, 4 cubed, so 4. You're okay, you're okay. Raised to the power, there we go, cubed. And then it was minus 4 times 4. So this is what I would type into my calculator. 12 times 4 cubed minus 4 times 4. Big number, 752. It's okay. It's okay. Shh. Okay. So that's my answer. That's kind of crazy. It's a big slope. Okay, so the slope of the tangent at 4 is 752, a very steep line. Okay, guys, I'm sorry. Hey, you're okay. Shh. Oh my gosh, okay. You're ruining Mommy's video. Okay, so we're going to continue. All right, so the next one is same story. So again, find the derivative. Okay, so f prime of x is 9x squared plus 4x, and the 10 goes away. Plug in the given value, which here it is, negative 2. And so 9 times negative 2 quantity squared plus 4 times negative 2. So we're going to go to our calculator. 9 times negative 2, make sure you do parentheses. Okay, then we're going to square that. And then it's plus 4 times negative 2. Enter. That's 28. Okay. It was positive. Okay, so that is my slope. So f prime of negative 2 is 28. In other words, the slope of the tangent at negative 2 is 28. Another steep line, not as steep as the last one though. Okay, so all we're doing to find the slope of the tangent at the point, find the derivative, plug in the x value. Now the next one might throw you off a little bit. Instead of giving you an x value, I'm giving you a point. But for right now, all I care about is the x value. So this is the same story. I'm just plugging in the x value only, right? For today, we're going to ignore the y value of the point. So same thing. Find f prime of x. That's going to be 18x squared plus 2. The 4 goes away. Found the derivative. Plug in the point. This one I think I can actually do in my head. Gorgeous. 1 squared is 1, so 18 times 1 is 18, plus 2 is 20. So, f prime of 1 is 20, which means the slope of the tangent is 20. So the m, remember guys, m stands for slope, mx plus b. So that's why I'm writing my final answer as m, because it's not asking for the derivative, it's asking for a slope. That's a technicality. I won't be too strict on that. All right, last but not least, f prime of x drop down the 2. So that's negative 2x plus 14. The 3 goes away. Perfect. Let's plug in 7. So f prime of 7, negative 2 times 7 plus 14. Well, that's negative 14 plus 14, so f prime of 7 is 0. Oh, and my son just burped. Wow, what a video. What a video. So the slope of the tangent line is 7. I'm off, guys. The slope of the tangent line is 0. And that's what we got when we plugged in 7 to the derivative, okay? Whew, I hope that made sense. It was hopefully a lot of repeated actions. In other words, for every single one of these problems, we're taking the derivative, and then we're plugging in a value to the derivative. That value that we get at the end after we plug in the x value, the number we get is the slope of the tangent line at that particular x value. All right. Hope that makes sense. We'll move on and do one more thing after this next week, but that'll be it for this unit. Hang in there, guys.